Welcome. Today we're mapping the architecture of an AI product manager. We'll cover the transition from traditional software to AI, the mechanics of machine learning, how to control large language models, and the necessity of RAG architecture. All resource links are in the description below. As an AI product manager, you don't need to write code. However, without technical literacy, you risk requesting features that are either technically impossible to build or commercially unviable to maintain. Traditional software is deterministic. Engineers write explicit rules, and when a user provides an input, those rules guarantee a specific, predictable output every time. AI systems are probabilistic. Instead of following rigid instructions, they rely on statistics to generate an output that is likely based on patterns, but never absolute. Product design now focuses on managing uncertainty rather than managing code. The same input provided today may result in a different output tomorrow. Your role is to harness these unpredictable models to build software that meets the strict reliability standards of an enterprise environment. Machine learning is statistics applied to patterns in data. Think of it like teaching a child to recognize a dog. Instead of strict rules, you show them thousands of pictures, labeled dog or not dog. The model identifies statistical weights purely by processing those examples. This creates a specific limitation. The model only knows the information it was exposed to during its training phase. When the system encounters an unseen pattern, it will either guess poorly or generate an output that is confidently incorrect. Your responsibility is auditing the training data to ensure it accurately represents the users who will actually interact with the product. Large language models like GPT-4 use these statistical patterns to predict the next most likely word by analyzing billions of parameters across human language. You control these models per specific settings. The first is the context window, the active working memory for a prompt. Allowing the model to see more text enables complex reasoning, but increases compute cost and generation time. The second parameter is temperature, which dictates the randomness of the output. For a financial tool, you set temperature to 0 for consistent answers. For brainstorming, you move toward 1 to allow for more varied responses. These parameters allow you to shape the behavior of an AI feature without needing to change the underlying architecture. Because LLMs are predictive, they can hallucinate, meaning they generate factually incorrect information with total confidence. This is a byproduct of how the models are built. It is not a software bug that can be fixed with more code. A standard LLM is like a student taking a closed-book exam. They can only rely on what they memorized during training, even if that information is now outdated. To solve this, we use Retrieval-Augmented Generation, or RAG. This architecture intercepts the user's prompt and searches a live private database for relevant, up-to-date information first. Those facts are fed to the model, turning the process into an open book exam, where the model provides a synthesis based on verified sources rather than memory alone. RAG allows a PM to ground a probabilistic model in factual reality, making it reliable enough for enterprise use. Deploying these systems no longer requires a large team of specialized machine learning engineers. Microsoft Power Platform and AI Builder provide environments where PMs can deploy AI capabilities through a visual, modular interface. This allows businesses to integrate AI directly into existing tools like CRMs or automated support desks without building the infrastructure from scratch. The modern AI PM focuses on system integration and user experience, leaving the low-level architecture to these established platforms. Deploying probabilistic systems without guardrails creates a structural liability. Without limits, the system can fail when it encounters data it wasn't designed to process. Responsible AI principles are foundational design constraints. They are not a final step. They dictate the product's requirements from day one. At Microsoft, these are fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. You apply these by auditing data to hunt for bias. Privacy principles ensure sensitive company data remains protected and never leaks into public training sets. A product that fails its responsible AI metrics is non-functional, regardless of the capabilities of the underlying model. A core skill for this role is knowing when not to use AI. If a simple, rule-based system is cheaper and more reliable, that is the correct product decision. Your value is in understanding these limitations, governing the data, and designing interfaces that help users trust the output appropriately. To start your own portfolio, check the Microsoft Learn Paths and AI 900 resources linked in the description. Thanks for watching.